Section 10.1b is about symmetry and vertices. Parabolas that we learned about in the first section have a geometric property called symmetry. Now, figures that have this property can be folded in half so that each half matches the other exactly. I'm going to try to do a couple quick sketches to illustrate that. If I have a circle and I put a dotted line right down the middle, in theory, if my drawing wasn't so bad, you would see that the left side matches the right side just like it was looking in a mirror. That's symmetry. Same is true for a square. A square is considered symmetrical because you can put a line down the middle and the left side matches the right side as if you're looking in a mirror. Certain triangles are symmetric, not all of them, but if you can put a line down the middle, that's what symmetry is. And parabolas are symmetrical. There is a line that exists that you can put right down the middle so that the left side will match the right side as if it's looking in a mirror. That's what symmetry is. Now, there's a formula in algebra to find this axis of symmetry, is what it's called. X equals the opposite of b over 2a. Now, why x? Because if you'll remember from past lessons, you learned that x equals a number is a vertical line. And each one of these red lines is the vertical line that cuts them all in half. So this is how you find the axis of symmetry. You take the opposite of b over 2a. Now, what you might be asking yourselves is, where do you get this b and this a? Well, remember that a quadratic equation has this general form: ax squared plus bx plus c. So if you have a quadratic that looks like that, you can take the b, which is the coefficient of the middle term, and the a, which is the coefficient of the first term, plug them into this, and this will help you find the equation for your axis of symmetry. So in this example, I'm going to graph this quadratic equation, but rather than just plugging in a bunch of points, I'm going to find the axis of symmetry, then find the vertex. I'm going to graph it, and then tell if it's a maximum or a minimum. So we start with the first step, finding the axis of symmetry. So our formula is opposite of b over 2a, so I'm going to use my quadratic equation here. The b is negative 8, so we do the opposite of b, opposite of negative 8, over 2 times a, which is negative 2. So this is positive 8 over negative 4, which is a negative 2. So we say our axis of symmetry is x equals negative 2. So I'm going to go to my graph now, and I'm going to put a dotted line where x equals negative 2. And remember, a vertical line is x equals a number, and this is where the x's all are negative 2. So that's what this axis of symmetry is, x equals negative 2. The second step is to find the vertex. Now, the way you find the vertex, since the vertex is on the axis of symmetry, that means its x value is negative 2. So I'm going to take my quadratic equation, and instead of x, I'm going to replace all the x's with negative 2's. And then by using algebra, I'll be able to find what the y value is, and that will give me an ordered pair. Negative 2 squared is 4, times negative 2 is negative 8. This is a plus 16 and a minus 2. Well, negative 8 and 16 is 8, and 8 minus 2 is 6. So when I plug in a negative 2 for my x, I get a 6 for my y, and that is my vertex. So I'll go to my graph. Here's negative 2, 6. That is my vertex. Now, one more thing I want to point out, and I'll write this as y equals negative 2x squared minus 8x minus 2, so I can have it in front of me. Remember, we talked about in section A that negative in front of the squared term means the parabola opens down. So I know my parabola is going to open down here. So I'm going to put my ordered pair negative 2, 6 right here, just so that I remember that that's what the vertex is. Now, the next thing I have to do, we'll call this step 3, is find points and use symmetry. Now, what do I mean by find points? I mean, since x was a negative 2, the next x values that I want to try are either going to be negative 1, which is just to the right of it, or negative 3, which is just to the left of it. So I'm going to plug a new x value in. And I'm going to try x equals negative 1. So I'm going to replace all my x's with negative 1's. So negative 2 times positive 1, because negative 1 squared is positive 1, is negative 2 plus 8 minus 2. So that looks like a 4. So that gives me an ordered pair of negative 1, 4. That's a point that's on my parabola. So I go over here and I do negative 1, 4. There's a point. Now here's where the symmetry comes in. If I have a point that is 1 unit away from my axis of symmetry, then because symmetry cuts my parabola right in half, I know that there has to be a point that's also 1 unit on the other side of the parabola, which means there has to be a point here. I don't have to do any algebra to find that. And that point is negative 3, 4. So I know that there's a point right there. And that's the benefit of symmetry. Once you have a point on one side, you can find the point on the other side. Now the next x value I'm going to try is going to be 0. I did negative 2, negative 1. Now I'm going to do 0. 0 times anything is 0. 0 times anything is 0. So when I plug in a 0, I get a negative 2. So here's 0, negative 2. Again, symmetry says that that's 2 units away, which means there also must be another symmetrical point 2 units on the other side. And if this is 0, negative 2, this has to be negative 4, negative 2. Now, I'm going to graph my parabola by just connecting my dots. That could be better, but you get the idea. And there's my parabola. And I was able to find the axis of symmetry. I was able to find the vertex. I graphed it. Last thing I have to do is tell if the vertex is a maximum or a minimum. Well, if the vertex is up here and it goes down, it has to be a maximum. Here's another quadratic equation that I'm going to graph. Before I find the axis of symmetry and vertex, I want to talk about this maximum and minimum. Well, because you know that the A term, in this case a 3, is positive, you know the parabola is going to open up. And because it opens up, you can say right now that this parabola is going to have a minimum. So you already have an idea in your mind of which direction the parabola is going to open. I wanted to point that out as a possibility. You don't have to wait till the end to find the maximum or the minimum. All right, to graph this, we'll start by finding the axis of symmetry. So in this parabola, my b is negative 6, so do the opposite of the negative 6 over 2 times a, which is 3. So this is positive 6 over 6, which is a 1. So my axis of symmetry is x equals 1. Go to my graph, and I'll draw a dotted line where x equals 1, and that is my axis of symmetry. Now I know my parabola is going to open up, so I'm going to put x equals 1 down here just to keep it away from the parabola itself. Now I'll find the vertex. Remember, to find the vertex, you plug the x value in, the x in the axis of symmetry in for all the x's. 1 squared is 1 times 3 minus 6 plus 1. That's a negative 3 plus 1 is negative 2. So my vertex is 1, negative 2. Go to my graph. Let's do 1, negative 2 right here. That's my vertex. Now, I'm either going to plug in points to the left or to the right. So I'll either do 0 and negative 1 or 2 and 3. Now, I always like 0, so I'll plug in 0 for the x. So 0, 0, and 1. So when I plug a 0, I get a 1. And then I said the other x value I was going to try is negative 1. Negative 1 squared is 1 times 3 plus 6 plus 1. So this is a 10. So when I plugged in a negative 1, I got a 10. So 0, 1 and negative 1, 10 are my 2 points. Here's 0, 1, and here's negative 1, 8, 9, here's negative 1, 10. Now we've talked about symmetry. If there's a point that's 1 unit away, over here there better also be a point that's 1 unit away on that side, and if there's a point that's 2 units away from the axis of symmetry, it better also be 2 units away on that side. So this point, which is 2, 1, must be on my parabola, and so should 3, 10. And now I can connect the dots and draw my parabola. This one's very skinny. There you go. And we already said that the vertex is a minimum, and you can see that from the graph because it starts here and the parabola opens up.